The brilliant Isaac Asimov once said, "The most exciting phrase to hear in science, the one that heralds new discoveries, is not 'Eureka!' but 'that's funny.'" Some of the best discoveries in history weren't exactly planned out. They were, as Bob Ross would say,
happy accidents.
In this video, I'm going to list the top 10 accidental discoveries in chemistry. Make sure to let me know in the comments if I miss any out, and let's get straight into it. In the mid-1800s, there was a scientific revolution occurring in Germany. With Friedrich Wöhler's discovery that an organic substance, urea, could be synthesized from inorganic compounds, and with August Kekule's introduction of the concept of chemical structure, a new field of science was exploding in popularity: organic chemistry. The American chemist Ira Remsen was studying in Germany at the time and learnt all about this amazing new science. Upon returning to his home country in 1872, he became the first chemist to introduce America to the wonders of organic chemistry and established a lab at Johns Hopkins University. A postdoctoral researcher working for Remsen was the Russian chemist Konstantin Thalberg, who was investigating compounds that had been derived from coal tar. Here's Thalberg's own words about one particularly interesting evening in June 1879. "One evening I was so interested in my laboratory that I forgot about supper until quite late, and then rushed off for a meal without stopping to wash my hands. I sat down, broke a piece of bread and put it to my lips. It tasted unspeakably sweet. I did not ask why it was so, probably because I thought it was some cake or sweetmeat. I rinsed my mouth with water and dried my moustache with my napkin when, to my surprise, the napkin tasted sweeter than the bread. Then I was puzzled. I again raised my goblet and, as fortune would have it, applied my mouth where my fingers had touched it before. The water seemed syrup. It flashed upon me that I was the cause of the singular universal sweetness, and I accordingly tasted the end of my thumb and found that it surpassed any confectionery I had ever eaten. I saw the whole thing at a glance. I had discovered some coal tar substance which out-sugared sugar. I dropped my dinner and ran back to the laboratory. There, in my excitement, I tasted the contents of every beaker and evaporating dish on the table. Luckily for me, none contained any corrosive or poisonous liquid. When Thalberg found the chemical, he noted that it was hundreds of times sweeter than sugar. This was the first artificial sweetener ever produced. He named the chemical saccharin after the Latin word for sugar, saccharum, and started a company in Germany to manufacture it on a large scale. So, the next time you're reaching for a sachet of Sweet and Low, you can thank Konstantin Thalberg for not washing his hands on that fateful day. By the way, there's a word for accidental discoveries of this nature: serendipity. I was recently reading an article about serendipity in computer science, which had what seemed like some fascinating examples, although a lot of it went right over my head. Sadly for me, you see, I'm a chemist and terrible at coding, but I've always wanted to find a fun way to learn. That's why I'm happy to be partnering with boot.dev, who are the sponsors of this video. Boot.dev is a website that allows you to learn back-end web development in programming languages like Python and Go from start to finish, and the way they teach you is really cool. The lessons come in the form of an RPG, where you gain XP, level up, find loot, and complete quests. They did really well to gamify the learning process and make it fun, so that you want to progress with your learning until you achieve your goals. For example, they have an AI-powered bear wizard called Boots, who can help you when you're stuck by asking you questions to guide you towards the correct answer. However, it costs a baked salmon to ask Boots questions, so if you're running low on loot, you can always check your trusty spellbook to look back over what you've already learnt. You can't learn to code without doing a load of coding and building real projects, and boot.dev has a huge catalogue of courses to choose from. Go to boot.dev and use my code CHEMISTORIAN to get 25% off your entire first year if you choose the annual plan. Okay, back to the video. Early refrigerators used toxic or flammable gases as refrigerants, such as ammonia, sulfur dioxide, and ethene, which led to a series of fatal accidents. As a result, by the 1930s, manufacturers began introducing a new class of non-toxic, non-flammable refrigerants, chlorofluorocarbons, or CFCs. Now, these would go on to unleash an entirely different problem on the world by wreaking havoc on the ozone layer, but that wouldn't be noticed until the 1970s. In 1938, when CFCs were still beloved, an American chemist called Roy J. Plunkett was working for the chemical company DuPont. He was part of a team that was attempting to synthesize new CFCs. One route they followed was to try and chlorinate tetrafluoroethylene, or TFE. Plunkett produced a large volume of gaseous TFE and stored it by compressing the gas into small cylinders and leaving them overnight at low temperatures, ready to chlorinate the following day. Here's Plunkett's own account of the next morning. On the morning of April 6, 1938, Jack Reebok, my assistant, selected one of the TFE cylinders that we had been using the previous day and set up the apparatus ready to go. When he opened the valve to let the TFE gas flow under its own pressure from the cylinder, nothing happened. We were in a quandary. I couldn't think of anything else to do under the circumstances, so we unscrewed the valve from the cylinder. By this time, it was pretty clear that there wasn't any gas left. I carefully tipped the cylinder upside down and out came a whitish powder down onto the lab bench. When they analyzed this waxy white solid, they found that the TFE had polymerized into polytetrafluoroethylene, or PTFE. Although Plunkett initially considered the experiment a failure, when they investigated the solid, they found that PTFE had some amazing properties. It was extremely slippery, as well as inert to virtually all chemicals, including highly corrosive acids. In 1942, the US military used PTFE in the Manhattan Project as a coating to prevent corrosion by the highly reactive uranium hexafluoride. After the war in 1945, DuPont trademarked the substance under the name Teflon, and eventually found large-scale uses for it in cookware, where it provided a non-stick coating. By 1961, demand in the US for the Teflon Happy Pan had reached a new high, with 1 million pans sold every month. However, it was later discovered that exposure to PTFE and similar materials can result in it building up in the human body. And due to the inertness of these materials, once they're in, it's very difficult to remove them. As such, they've become known as forever chemicals, and these forever chemicals are known to cause problems such as infertility and cancer. So it's best to limit your exposure as much as possible. Following the discovery of PTFE, another American chemist at DuPont named Bill Gore saw the potential in this substance. He wanted to investigate whether he could produce an insulating material to wrap around wires. He built a laboratory in his home and installed a roller machine to try and create large, wide sheets of PTFE from the powdered form. He enlisted the help of his wife, Vive, and the two would spend their nights and weekends trying to get his idea to work, but they were unsuccessful. Any sheets that they produced were full of cracks, and it seemed like the particles were unable to adhere together, let alone to a wire. One day, Bill and Vive's son, Bob, who was a chemical engineering student, suggested that instead of using the powdered PTFE, they try and use Teflon tape, which Bill had lying around to use as a thread sealant. Bill tried it and found that it worked perfectly. The two strips adhered around the wires, resulting in an insulating layer. Due to this promising result, Bill left DuPont and, along with his wife, established W.L. Gore and Associates on the 1st of January 1958, the day of their 23rd wedding anniversary. They employed other DuPont scientists and continued their research in their home laboratory. And, as they began promoting their custom wiring products over the next few years, the company grew, eventually supplying wiring for the expanding computer industry and even to the NASA Apollo missions. After completing his studies, Bob joined his parents' company and went on to lead the R&D department. One day, in 1969, he was tasked with producing a PTFE replacement for plumber's tape, which needed to be able to be stretched 50 times its length. He went to the lab and began experimenting with stretching rods of PTFE. Very slowly, he stretched a rod, but it just snapped. He tried over and over again, but no matter how careful he was, the rods kept snapping. Eventually, he got fed up and gave a rod a frustrated yank, but to his amazement, it remained intact. When they analyzed this expanded PTFE or ePTFE, they found a microporous structure that was about 70% air. It was waterproof and highly breathable. Bob and his team immediately began researching it and saw the amazing potential. Shortly afterwards, Gore patented the substance under the name Gore-Tex, and the material became widely used in clothing and equipment for hiking. So, since Gore-Tex was accidentally discovered by a frustrated yank of a PTFE rod, we could call it a second-generation accident, an accidental discovery from another accidental discovery. In the forests of South Asia, you sometimes find a buildup of a waxy resin called shellac. These deposits are secreted by the female Coriolanca insect, also known as the lac bug. Shellac has been used for centuries as a varnish for wood, but considering it's obtained from the secretions of South Asian insects, it was always an expensive substance. In the early 1900s, a Belgian chemist called Leo Baekeland was working in his home lab in New York, trying to produce a synthetic alternative to shellac. In recent years, other chemists had produced resin-like substances by reacting formaldehyde and phenol together, but the results had always been a sticky mess. Baekeland experimented with this reaction at different temperatures and pressures and eventually produced a soluble resin that was pretty similar to shellac. He named it Novolac, from the Latin word novus, meaning new. However, its properties weren't as good as those of shellac and it wasn't a commercial success. By 1907, Baekeland was frustrated with his unsuccessful attempts at trying to synthesize a coating for wood, and he had a more interesting idea. What if you could impregnate the wood with a synthetic resin in order to strengthen it? He heated up some wood under pressure with a mixture of formaldehyde and phenol, and afterwards, when he examined the wood, he wrote in his lab book, "The blocks of wood do not feel hard, although a small part of gum that is oozed out is very hard." When Baekeland investigated this substance, he found that it was moldable while hot, but very hard when set. This was the first ever fully synthetic plastic. He named it Bakelite after himself, quickly obtained a patent, and began mass producing it, single-handedly kick-starting the modern plastics industry. A century later, not only is the planet covered in plastic waste, but microplastics are being discovered everywhere, from drinking water to human blood. Baekeland could never have known the impact his material would have on the planet, but since we know better today, the least we can do is recycle the plastic we've already got. We don't need any more. In the 1830s, an interesting new material from the jungles of South America and Asia was gaining traction in the United States: rubber. It was pliable and waterproof, and entrepreneurs began manufacturing bags and life preservers out of it. However, there was a problem. When rubber got too cold, it became brittle and cracked. When it got too hot, it melted. Rubber entrepreneurs were at risk of going bankrupt because their products kept failing. The American chemist Charles Goodyear knew that if he could find a way to strengthen and stabilize rubber, he could earn a fortune in this emerging industry. He would spend his days experimenting with rubber in the kitchen, reacting it with various chemicals to see what would happen. Over the course of 5 years, he spent all of his money on these experiments and took out loans which he was unable to repay, which landed him in debtor's prison. But he managed to continue his experiments from behind bars. One day, back in his kitchen, he was trying to combine some rubber with sulfur when he accidentally dropped the mixture onto the hot stove. He watched in amazement as, instead of melting as it usually did, the rubber stayed solid. He increased the heat and saw that the rubber actually got harder. He'd done it. He obtained a US patent for his process in 1839 and named this strengthened rubber Vulcanized rubber, from the Roman god of fire, Vulcan, which is where we get the word volcano. Suddenly, rubber was everywhere. Hoses, shoes, toys, tires, and so much more began incorporating vulcanized rubber. Goodyear himself spent the rest of his life fighting in court cases for patent rights around the world. and he died $200,000 in debt. Almost 40 years after his death, in 1898, the American entrepreneur Frank Seiberling founded the Goodyear Tire and Rubber Company, named in honor of Charles Goodyear. Today, it's one of the largest tire manufacturers in the world, selling millions of tires every year. In 1859, the American businessman Edwin Drake spent the last of his funds digging for oil in Pennsylvania. He had spent a fortune on failed attempt after failed attempt. However, on the 27th of August, he finally found what he was looking for, making him the first American to successfully drill for oil. Shortly afterwards began the Pennsylvania oil rush. People swarmed to the area from all over the country as oil wells and refineries shot up across the region. One person who traveled to Pennsylvania in this time was the American chemist Robert Cheeseborough. Previously, he had spent his career producing kerosene from sperm whale oil. However, all of a sudden, people were realizing how much easier it was to dig for oil rather than hunt whales in the middle of the ocean. As a result, the whaling industry quickly declined, along with Cheeseborough's livelihood. He made his way to Pennsylvania to see if he could find any interesting materials from this new oil. As he walked around the oil rigs and talked to the workers, they told him about what they called rod wax, which kept building up on the machinery and caused it to malfunction. The workers regularly had to stop the machines to clean it off. However, they also noticed that it soothed their skin when rubbed onto cuts and burns. Cheeseborough was immediately interested in this substance, so he took a sample of it back to his lab. Over the next few years, he discovered a way to refine the thick black wax into a thinner, lighter colored gel which had excellent skin-soothing properties. Excited by his discovery, in 1870, Cheeseborough opened a factory in Brooklyn, New York, and toured the entire state in a horse-drawn carriage to promote this miracle product. During public demonstrations, he would deliberately burn his skin, then apply his gel to show its soothing ability. This dramatic marketing worked, and sales rapidly increased. In 1872, he patented his refining method and gave the gel the name Vaseline, from the German word Wasser for water and the Greek word eleon for oil. Within 2 years, his company was thriving, with a tin of Vaseline being sold every minute in the United States. Cheeseborough was such a believer in Vaseline that he actually ate a teaspoon of it every day, claiming that it was good for his health. He lived until he was 96, so who knows, maybe he was right. I can't believe I'm saying this, but just to be clear, that was not a recommendation to eat Vaseline. Okay, on to the next one.
Here is a plane containing hundreds of plastic parts. Here another bonded by plastics. This paratrooper floating down to welcome Mother Earth is depending on plastics to get him there safely.
By the 1940s, the plastics industry was in full swing, and it was an important part of the war effort. An American chemist called Harry Coover was leading a team who were attempting to develop clear plastic gun sights, which were, in theory, less brittle than glass gun sights. The team were investigating a class of chemicals called cyanoacrylates, which could be synthesized as a clear gel, but it was very difficult to mold them into useful shapes as they set. The gel was extremely sticky, and the researchers found it impossible to work with. Back to square one. They rejected cyanoacrylates as a feasible option for gun sights and moved on with their research. After the war, Coover got a job working for the Eastman Kodak Company. In 1951, he was involved in a project investigating polymer materials to be used for jet canopies. He decided to give cyanoacrylates a second chance, and the team got to work investigating them. A member of Coover's team called Fred Joyner was tasked with measuring the refractive index of the gel. The standard way of doing this is to place a thin layer of the liquid between two clear prisms and shine light through it at different angles to measure the amount of refraction. After Joyner did this, he found it impossible to separate the two prisms and started panicking that he had destroyed some expensive equipment. However, when Coover learned about what happened, he realized the commercial potential of this substance as an adhesive. Coover filed for a patent for the substance in 1954, and in 1958, the Eastman Kodak Company began selling it for industrial use under the name Eastman 910. The following year, to promote Eastman 910, Coover appeared on the popular TV show I've Got a Secret, where he applied a single drop of the adhesive between two steel cylinders, sealed them together, and demonstrated how the bond was strong enough to lift himself and the host Gary Moore off their feet. Interest in Eastman 910 increased, and it was later rebranded under the name Superglue and sold to the general public. It's a strange coincidence that one of the slipperiest substances ever and one of the stickiest substances ever were both discovered by accident. The German-Swiss chemist Christian Friedrich Schönbein was well accomplished in the field of electrochemistry. In 1838, he observed how electrodes became charged and discharged when exposed to different solutions and gases, and he developed one of the first ever fuel cells. In 1840, when doing experiments on the electrolysis of water, he noticed a distinctive smell filling his laboratory and recognized it as the smell often following electrical sparks or a bolt of lightning. Shortly afterwards, he succeeded in isolating the gaseous chemical that was causing the smell, and he named it ozone, from the Greek word ozein, meaning to smell. One day, in 1845, while his wife was out, he was doing some experiments in his kitchen, when he accidentally spilled a mixture of nitric acid and sulfuric acid. He grabbed his wife's apron, mopped it up, and hung the apron over the stove to dry. Moments later, he was stunned to see the apron burst into flames. It ignited so rapidly that before he could do anything, it seemed to just disappear. Schönbein couldn't believe what he'd just witnessed. With some more experiments, he realized that he'd accidentally nitrated the cellulose in the cotton fibers of his wife's apron and produced a substance that he called nitrocellulose, which later became known as gun cotton. It had around 6 times the gas generation of an equal volume of gunpowder, giving it much higher blasting power. On top of that, it produced a lot less smoke. By the way, nitrocellulose is not the same as the similarly named explosive nitroglycerin, which was discovered only a year later in 1846, and has an equally interesting story. I've actually already made a video about that one, so I'll link it in the description below. In 1669, a German alchemist called Hennig Brandt was attempting to create the Philosopher's Stone, which would allow him to convert base metals into gold. His method of making the Philosopher's Stone involved boiling down around 1,500 gallons of urine. The golden color of urine was thought to be related to metallic gold in some way. After boiling it down, he was left with a thick, oily substance, which he transferred to a retort and, after some intense heating, eventually brightly glowing fumes burst out from the oily substance and filled the retort. At the same time, a liquid dripped out of the neck, erupting into flames. He caught the liquid in a jar and covered it where it solidified. As he watched it, he saw that there was a pale green glow coming from the solid, which never went away. Can you imagine what Brandt must have been thinking? To him, he must have thought he'd done it. He'd successfully created the Philosopher's Stone. He gave the substance the name Phosphorus, from the Greek word phos, meaning light, which is the same root as the word photo, and phero, meaning to bear or to carry, which is the same root as the word pheromone. Unfortunately, no matter what he tried, Brandt couldn't find a way to get phosphorus to convert base metals into gold. However, he had unknowingly become the first person since the ancients to discover a new element. I really love this story. It was a monumentous discovery that changed the course of history. In fact, the only reason I didn't put it at number 1 is because I already have an entire video about it, which I'll link in the description so you can hear the full epic tale. In the 1800s, colonialism was all the rage for the major powers in the world. However, there was one major problem that was preventing the European powers from establishing colonies deep into Africa: malaria. A known treatment for the disease was a compound called quinine, which was extracted from the bark of the cinchona tree. However, since these trees are only found in tropical Andean forests in South America, quinine was expensive and hard to come by. So the synthesis of artificial quinine would be a major breakthrough. The German chemist August Wilhelm von Hofmann decided to challenge a student of his with this problem. The student in question was the English chemist William Henry Perkin, who was just 18 at the time. A compound that von Hofmann was researching at the time was called aniline. So during the Easter holidays in 1856, Perkin took some back to his home and began investigating it. One thing he tried was oxidizing the aniline, using an oxidizing agent called potassium dichromate. However, after the reaction, he was left with a black solid in the bottom of his flask. Definitely not quinine. He got some ethanol solution to rinse out his flask so he could try something else. But when he poured the ethanol in, it created a vivid purple solution. He accidentally got some on the sleeve of his lab coat and found it impossible to wash off. Perkin realized that he had inadvertently produced the first ever synthetic purple dye. This was an amazing feat since, up until then, natural purple dyes had been very hard to come by and were extremely expensive. In ancient Greece and Rome, purple dyes were made from the mucus of sea snails, so only the wealthiest people could afford to wear purple garments, and hence the color's association with royalty. Perkin immediately realized the commercial potential of his synthetic dye. He named the color mauve, after the French name for the mallow flower, fleur de mauve, and later the dye itself became known as Mauveine. He quickly patented his method and opened a factory to mass produce Mauveine. Although he initially only had modest success, a couple of years later in 1858, Queen Victoria herself wore a rich mauve lace-trimmed gown with a matching petticoat to her daughter's wedding, causing an explosion in demand for the colour. Before long, mauve was all the rage in Victorian England. Walk down the street in Victorian London and you'd see mauve everywhere. The satirical magazine Punch referred to the rapid spread of the colour's popularity as the mauve measles. Perkin's synthetic dye industry became hugely successful. This was the first industry of its kind, an industry that used chemistry on a large scale. So, not only did Perkin's accidental discovery result in the Victorian era becoming a bit more colourful, it also resulted in the birth of what would become a behemoth sector of industry, the sector of industrial chemistry, without which our modern society simply would not exist. Let me know in the comments below of any other accidental discoveries, and if you made it this far and you want to help out the channel, please consider liking and subscribing. Thanks for watching, and I'll see you in the next one.